So over here, 5, 3, and 1. All of these are same side, right? Same side. Which ones are alternate to 7? 6, 8, 4, and 2 are alternate. We got to know these words, okay? So let's go to slide 5. As I recall, we started this one, but we didn't get very far into it, right? So why do I have the yellow dots where I have them? How do I know? And I just lost, there we go. How do I know that the yellow dots, deep breath technology. Why do the yellow dots go here inside? Because I'm talking about same side of the transversal and interior, right? So I can put my yellow dots here, or I can put my yellow dots here. I am. So these yellow dots can either go on the right side or on the left side because they're same side interior. It does not matter. They can go either place. And then I've got same side exterior. So they've got to be on the same side of the transversal, but outside of those parallel lines. So I can either put them where the orange dots are, or I can put them where I just do the green dots, okay? Same side of the transversal, but inside or outside of the parallel lines. Over here with corresponding, we want congruent angles, right? So either they're both going to be acute, like they are here, or they're both going to be obtuse, like they are here. But they can move around. So there's 4 sets of corresponding angles here. We've got another set of acute angles here and here. They've just slid down. So if I'm at the southeast side of the street and then the southeast side of the street, sometimes that helps. Or I can look at my obtuse angles and be at the southwest side and the southwest side. So that's what this note is over here. What I want you to do is write in this box, take a minute and make sure that you understand the difference between same side interior, same side exterior, and corresponding. All 3 of these patterns are on the same side of the transversal. The one sits inside the parallel lines, one sits outside the parallel lines, and one side, one is in and one is out. Okay, we're going to practice this in a minute. We need to know the vocabulary. So if you need a minute to make those notes, please do that. For those who just joined us, Mason, I know you just came in, we're in that digital notebook. Any question on same sides, guys? Should we go to slide 6? Okay. Somehow my mouse, there we go. So we've got some different vocabulary here. We know the vertical angles. Those were from last unit, right? So vertical angles. Can either be the 2 green ones, or they can be those 2 blue ones. Or we could come down here and we can do the other intersection, the 2 acute angles. The trick with vertical angles is they're going to be congruent, right? So next to vertical angles, you want to write congruent in this orange box. The symbol is congruent. And they're going to be in the same intersection. So in this box, please type that they are in the same intersection and they are congruent, vertical angles. That's from last unit. Congruent and same intersection. Linear pairs, same thing. They're going to be in the same intersection. So both of these are in the same intersection. I can't spell. Same intersection. But with linear pairs, they're going to form a straight line. So here with linear pairs, they're going to be on the same side, either on the east side or the west side, or they could be on the north side and the south side. Okay, so linear pairs are either going to be the two at the top or the two at the bottom, the two at the left or the two on the right. They're also going to be congruent. They're not going to be congruent. They're going to be supplementary. They're going to add to 180. My bad. Change that. Okay. Vertical angles are congruent. Linear pairs equal 180. So we've got vertical angles and linear pairs. Questions about those from last week? Okay. Over here on the right side, we've got alternate. Alternate means they're on opposite sides of that transversal, and then interior is where I'm going to run them over if I'm driving down this road. So I've got a pair of obtuse interior angles and a pair of acute interior angles. These are going to be congruent every time. They're going to be equal. Okay. So my interior angles that are acute and my interior angles that are obtuse. You can kind of make a Z right here. If you highlight the angles, it kind of looks like a Z. That's how you can see alternate interior angles. Okay. Then we've got these alternate exterior down here. They're going to be on opposite sides of the transversal. So again, if you highlight that transversal, I've got one on the left and one on the right. They're outside the parallel lines. And they can either be two acute angles or two obtuse angles. So I can either look at these obtuse ones or the acute ones that were in purple. Okay. Anybody need another minute to make those notes? Hopefully you made the notes last night and this was just a review. Okay. We're going to jump to page 7 and see what that looks like in real life. Well, all together at any rate. Maybe. All right. Is it you, my friend? That was a lot of zooming. I swear this computer worked fine, third block. That's okay. I'm just trying to make my computer work. So I'll start sharing my screen in a second. Maybe. All right. Hopefully this works better. All right. If you go to slide 7, question number 1 over here, on the where I want it to be. I'm looking for alternate interior angles. What's an example of a pair of alternate interior angles? So I want opposite sides of the transversal and inside the parallel lines. So 3 and so I want alternate and interior. So on opposite sides, they also have to be in separate intersections. So I wasn't clear on that. So alternate interior angles are in separate intersections. So 3 equals 6. 3 and 4 would be a linear pair. So I want 3 and 6. What's another pair of alternate interior angles? What are my acute pair? 4 and 5. So 4 also equals 5. Alternate opposite sides of this transversal, but inside the parallel lines. Okay. So what would alternate exterior look like? And you should be able to just type in those yellow boxes. So if alternate interior are 3 and 6 and 4 and 5, what about alternate exterior? 2 and 7 for certain. 2 and 7. So we can write 2 equals 7. And somebody said another one, I just didn't hear it. Absolutely. 1 and 8. So 1 equals 8. Okay. The next one's kind of introduce a new word. It says same side consecutive. Consecutive just means that they're kind of next to each other. So that's a little bit of a, like with interior angles, it makes sense, but with exterior angles, consecutive doesn't make so much sense. So that's why we've kind of switched everything to same side. Same side interior angles. What's my example? There's 2 of them. Same side interior. 3 and 4 are a linear pair. They are inside, but they're not same side of the transversal. Is there a better answer? 3 and 5. So 3 and 5 are going to be same side. And because 1 is obtuse, the 3 is obtuse, and the 5 is acute, we're going to do 3 plus 5 equals 180. And I know that doesn't look like really great math, but remember we're talking about the measure of angle 3 and the measure of angle 5 equal 180 degrees. So they're same side of that transversal T, and they're inside of the parallel lines. And hopefully everybody's writing these in the boxes. What's the other pair of interior angles that are on the same side of the transversal? So 4 and 6, 100%. And this is 180. So angle 3 plus angle 5 is going to give you 180 degrees. Oh, the one above it. 2 equals 7 and 1 equals 8. So 2 equals 7 and 1 equals 8. And over here, we can write 4 plus 6 equals 180. 4 plus 6 equals 180. Okay. Same side exterior is going to do the same thing, except instead of being inside the parallel lines, we're outside the parallel lines. So instead of 4 and 6, we'll use what? 2 and 8, absolutely. 2 and 8. Are those going to be equal to each other, or are they going to equal 180? What do we think? So we have an obtuse angle here, just like we had an obtuse angle here. And then we've got an acute angle over here at 8. And an acute angle over here at 4. So if I have obtuse that's bigger than 90 and acute that's smaller than 90, are they going to equal or equal 180? They're going to equal 180. So we can do angle 2 plus angle 8 equals 180. Okay. Last one, I know you're mind readers, and you can say, what is same side exterior to angle 1? 1 and 7, absolutely. So 1 plus 7 equals 180. My mouse has decided it doesn't want to work anymore. Okay. Corresponding angles are some of the hardest ones. So let me see if I can slide down here a little bit further so you can see those a little more clearly. What corresponds to angle 1? And I'm going to see if I can drag these dots. Oh, they don't want to drag. Okay. What corresponds to angle 1? If that's the northwest corner of this intersection, what corresponds to angle 1? Somebody saying angle 5 in their head? So you can almost like put your hand up and be like, okay, I'm going to take angle 1 and I'm going to slide it down and it's going to be congruent to angle 5. It's like going down a slide. What corresponds to angle 2? If I take angle, absolutely, angle 6. So I take that upper right-hand corner and I just slide it down the transversal to angle 6. What about angle 3? Where does angle 3 go? Seven, which leaves 4 and 8, right? So put in whatever angle pairs you want in here, but know that there are 4 of them. 1 and 5, 3 and 7, 2 and 6, and 4 and 8. Corresponding angles are the hardest ones to get, okay? So if you can get corresponding angles and make those make sense to you, you're doing well. They do equal each other. Yes, they do. That's a great question. They are congruent. Because I've got an obtuse angle here and an obtuse angle here. They maintain. It's like they've just been slid. Like when you do transformations, reflections, rotations, all we're doing is sliding these like on a coordinate plane. So let's see what they look like in real life if we talk about a map. Everybody good with that? We come up to the top. I gotta find out why this computer is being so slow. Can I go to the top? All right. So we've got Princess Anne Road and Indian River, and Kempsville connects them. You can't get to, oh God. You can't get to Indian River from Princess Anne without going through Kempsville, according to this map. Now, whether that's actually true or not is a whole nother story. Which street represents the transversal? What are you going to type into this box right here? What's the transversal? Kempsville, absolutely. So you're going to write Kempsville in here. And name the angles that are on the interior of the parallel lines. So Indian River is one of the parallel lines. So let me ask it a different way. we've got these arrows, right? That means these lines are parallel. So Indian River is parallel to Princess Anne. If I want the interior angles, I want the angles that are inside those two parallel lines. So which angles are those? What's 2, 7, 3, and 6? Absolutely. So we're going to type in 2, 7, 3, and 6. Okay. Interior talks about inside the parallel lines. What are the angles on the exterior? If 2, 7, 3, and 6 are on the interior, what's on the exterior? One, 8, 4, and 5. Absolutely. Absolutely. So 1, 8, 4, and 5. And then angles 1 and 5, what's their relationship? Angles 1 and 5. So if I look at just angles 1 and 5, and I'm going to erase this a little bit so we can see a little bit better, hopefully. They are alternate exterior. They're outside the parallel lines, right? We're talking about 1 and 5. Outside the parallel lines and opposite sides of the transversal. What about 4 and 6? What's the relationship between 4 and 6? They are vertical. So 4 and 6 are vertical. What about 6 and 8? Corresponding. I take the 6, that obtuse angle that's in the upper right-hand corner, and I just slide it up to the new intersection. This one's corresponding. What is the next question? Which angle would be same side interior to 3? Same side interior to 3. Same side interior to 3. So I've heard 4, 6, and 2. What do we think? Same side interior to 3. So if I want the same side of the transversal, I need the left side. And I need interior, I need inside the parallel lines. So same side interior is going to be 2 and 3. Same side interior is going to be 2 and 3. And I think the next one said what corresponds to 4. Is that what the next question asks? And corresponding to 4 is 2. Mm-hmm. Does that make sense? 4 is on that lower left-hand corner of the intersection, and if I slide it up, it's going to slide right onto angle 2. Or if I'm standing on the corner at 2 and I slide down here, I'm going to end up on 4. Okay, corresponding is the hardest one. Yeah. We did do the 4, but we can do it again. What is the relationship between 1 and 5? That's the pink ones. Are they on the same side of the transversal or alternate? Alternate. And are they inside the parallel lines or outside the parallel lines? Outside. You got it. let's go see if we can practice this a little bit. So if you go back into Schoology, you can keep that notebook open so you can reference it if you want. Go into today's folder. Actually, go into yesterday's folder, day 1. Since we kind of ran out of time yesterday. And open up these angle task cards. And you tell me whether you want me to stop sharing or whether you want me to keep sharing. We can talk through as much as you want. I know some people have already done this. If you've already done this, you can go on to another thing. Ooh, Miriam, sorry. Didn't mean to show your beautiful picture there. I know, I'm not trying to. My computer's got a mind of its own. All right. All right, so what do we think? 2 and 6, what's the right answer here? Corresponding. 2 and 6, definitely corresponding. What about 3 and 16? Why alternate exterior? They're on opposite sides of that transversal and outside the parallel lines. What about 6 and 11? 6 and 11. No, if you're like, please come open the task cards and let's do these, right? So this is just a homework assignment. It would have been homework yesterday if we hadn't spent so long doing the test and I hadn't had so many technical issues. But I'd like to do it together today. So I want to make sure everybody understands these angle relationships. 3 and 16, you can do it with us. 3 and 16 are alternate exterior. 6 and 11, there's no transversal that connects them. So if you think about that map kind of idea, if my house is at 6 and the 7-Eleven is at 11, I can't go straight from 6 to 11 without going through 10 or 7. This is no relationship. And that's the first time we've talked about that. No relationship. If they are not connected by a transversal, there's no relationship. Okay. What about 4 and 7? What's the relationship there? Are they on the same side of the transversal or alternate? Same side. Are they inside or outside the parallel lines? Inside. So these are same side interior, right? So whatever same side interior is. I want to do a couple more together and then I'll give you some time to work on it by yourself while I do attendance. If we're going too slowly for you, move ahead. You don't need to stick with us. If we're going too fast, call me out and let's pause. So what about 3 and 6? What's that relationship? Alternate exterior, absolutely. So that's going to be F. What about 3 and 8? Are they on the same side of the transversal or alternate sides of the transversal? They're alternate. Are they inside the parallel lines or outside the parallel lines? Absolutely. So this one is going to be no relationship because they're not both. If they were same side and one's inside and one's outside, we'd have corresponding. But this is not one of those relationships that we've identified. Okay. What about 3 and 8? That's a throwback to last unit. Vertical. It is vertical. So whatever letter vertical is. What about 5 and 6? Is that a picture of linear pair? They're in the same intersection. So Last unit, unit 2, we did vertical and linear pairs at the very end, right? Probably still a little shaky for some of you, but linear pairs and vertical pairs are always in the same intersection. The alternate interior, same side interior, alternate exterior, and corresponding are always going to be in 2 separate intersections. That's how they're different. 5 and 6 is, somebody help her out. Linear pair. You guys want to try 3 on your own, or do we need to do some more together? What do we think? Okay. So they all have 3, 4 parts until we get down to question 5, and then it's a single question, right? So the first ones have so many parts because I want you to like really be able to see what they are. So let's work on those for a little while. We finished with them. Then let's see if we can move on to today's work. So if you go back into the folder, and go into day 2. We're not going to do the warm-up that's in here. But I do want to go look at the digital notebook for some problem solving. So we're going to use these, and sometimes when we use them and create expressions and equations with them, the angle relationships start to make more sense. So we're going to go back to this digital notebook for pages 8 and 9 real fast. And then what I've done is I've made a video. You're going to go do this paired practice, and you're going to do it on your own paper. You can get a copy of the Google Slides if you want it here. But you're going to click on my video, and you can watch me work out the left side of each of these problems, okay? You're going to work out the right side, and we should come up with the exact same answer. So if I get x equals -7 for this problem, you should be able to work out this problem and also get x equals -7, okay? So we're going to do these 2 digital notebook pages, and then I'm going to give you time to do this, okay? So let's go back to that digital notebook. Hopefully you already have that open, and hopefully my copy will work better. Oh my goodness gracious. It's like it's just too big a file and it doesn't want to work. So if you look at the equation for number 1, how would you set that up? If I'm looking for this angle down here, what's the relationship? I've got a transversal. I've got some parallel lines. Here they're very clearly marked. So what's the relationship between 79 and x? These are alternate interior. Alternate interior angles are congruent. So if this angle is 79, what's x? Also 79, absolutely, right? Alternate interior angles, this is an acute angle, this is an acute angle, they're always going to be congruent. What about in number 2? Here we've got same side interior angles, we've got our transversal, we've got our parallel lines. They're inside the parallel lines, but on the same side of the transversal. Here we've got one acute angle and one obtuse angle, so they're going to equal 180. So what math do we have to do? Absolutely. So what is 180 minus 124? 56. So this guy right here is going to be 56. Does that make sense? Kind of, sort of, maybe? So I've got my transversal. I've got my parallel lines because I've got the arrows here. They're on the same side supplementary. So sometimes that helps. Same side supplementary, same side supplementary. Always going to add up to 180 degrees. Come on, computer. So look over at question number 3. What's the relationship in question number 3? They are corresponding, and corresponding, oh my good Lord above. Corresponding are going to be congruent, right? So we're going to set those two expressions equal to each other as soon as my computer catches up to where my mouse wants it to be. So 11x equals 10x plus 9. We're going to do this the exact same way. We just have some expressions here. So we know corresponding angles just float down. They're going to be equal to each other. So on a scratch piece of paper, you're going to do 11x equals 10x plus 9. Which does give you x equals 9. Okay. In this question, I'm just asking you for x, but could I ask you what's the value of the angle? Yeah. What would you do if I asked you how big this angle actually was in degrees? Would you just substitute that in? 11 times 9, right? Okay. What about question number 4? How do I set this equation up? They're same side interior. So I've got one acute angle, that's this one, and one obtuse angle, that's this one. So they're going to add up to 180 degrees. Again, same side supplementary. So on a scratch piece of paper, add those up. 11x plus 3 plus 13x plus 9. And what do we get? 11x and 13x is 24x. Plus 12, and then we get 7. And if you plug that back in, you should be able to plug it in and get the acute angle and the obtuse angle, and they should equal 1. Okay. Go down to slide 9. Any questions on those? Go down to slide 9 and see if you can do them yourself. See what answers you get. You're going to do all 4 of them. I'm going to give you 2 minutes, see what you can do. Do all 4. Or do as many as you can in 2 minutes. And I'll stop sharing, so if you're at home, it's not taking up your screen. I want you to do all 4 problems on slide 9. Got about 60 more seconds. You're doing all 4 problems on slide 9. So to wrap up the question you're on, I'm going to share my screen. What'd you get for question number 1? 85. Any questions on number 1? What's the angle relationship here? Alternate interior, absolutely. I don't know why my mouse keeps disappearing. And what about question number 2? What's the answer to that one? 38, 100%. And what's the relationship in number 3? This is making me crazy. Are they same side or are they alternate in number 2? I'm sorry. They're same side interior, 100%. What about question 3? What do we get for an answer? X equals 11, for sure. Any questions on that? Okay. Let me see if I can get my slides to work. So we've got to collect the like terms. So 6x and 12x make 18x. And then you see a minus 18, so you've got to add 18 to both sides. So 18x, it's not even writing. Oh my God. Minus 18 equals 180. So if you add 18 to both sides, you're going to get 18x equals 198. And then x equals 11. And then question number 4, what'd you guys get? Anybody? I got 25 as well. So if we add these up, we get 7x plus 5 equals 180, right? These are same side interior, so they're going to be supplementary, same side supplementary. So when you combine the like terms, 7x plus 5 equals 180, or 7x equals 175, and x equals 25. Okay. What I'd like to give you now is the opportunity to do this work. So if you click on the video, again, that's going to show me working out all of these first problems on the left side, and you're going to work out these right problems. Okay. If you're not quite ready to do this and you want to go do the IXLs, the homework for the weekend is in here. So if you look back in day 2, you do have a homework puzzle piece right here. So we can talk about that if somebody wants to look at that in the next, 20 minutes. So you've got a homework puzzle piece. And then 4 of those questions in the video, you've got to put the answers in here. So at the very end, this isn't question 2 from the top, it's question 2 from the bottom. So you got to work your way through all of those practice problems that you're going to do right now in order to find what I'm talking about here. Okay, so make sure you watch that video. If you still need help, do the D3 and D4. They will 100% count, and that was mentioned yesterday. Optional practice IXL D4. Okay. I'll send you a Schoology message. Does everybody know in Schoology where to look for messages up here in this envelope? Are you getting my updates that I've been sending? Okay. All right, so to be clear, if you want to work on IXL, you can work on IXL. Please work on the paired practice from today and then discussion post for Monday. And as always, just shout out if you have questions. No, yeah, you're 100% allowed to leave. See you next week. I'm going to write you like a little note, but it's the paired practice in today's folder, the green puzzle piece, and then if you want the D3, D4. Mm-hmm. Yeah. Doherty. Mm-hmm. Mm-hmm. That's okay. Oh no. I saw it. I noticed. I'm glad. Yeah, I was impressed when I saw that you had already worked ahead since I noticed you were absent yesterday. Good job. Oh no. Good. I'm glad. Mr. Alvarez was kind of struggling. So, yeah. Welcome. Have a great weekend. Good, are you okay over there? I like the conversation I'm hearing back there. Keep talking about these things. Logan, how you doing over there? You have any questions? Okay. You're welcome. Hudson, how are you doing back there? Okay. You got any questions? Addie, can I help you with anything?